Hi, in this video I'm going to show you how to solve this problem using the property of conjugate. So this problem says we want to find this quotient and express the answer in the form a plus bi. Now, if the denominator of this quotient is a real number, then this problem will be so easy. Why? For example, if the denominator is 4, then to rewrite this quotient in this form, a plus bi, we just need to split this quotient into 23 over 4 plus negative I over 4. So the real part is 23 over 4, and the imaginary part is a negative 1 over 4, right? But the difficulty here is the denominator is not a real number. It is a complex number. So what are we going to do? Because we know the product of a complex number and its conjugate going to be a real number, right? So this tells me to change the denominator into a real number, I have to multiply this denominator by its conjugate, which is 3 plus I. And also, I have to multiply the numerator by 3 plus I. Otherwise, I will change the original quotient, right? So please keep in mind, this is very important. Every time we multiply the denominator or the numerator by something, you have to multiply the other by the same thing. So now this becomes 23 minus I times 3 plus I over 3 minus I times 3 plus I. Since the denominator is a product of a complex number and its conjugate, so it's going to be 3 squared plus 1 squared, which is 10. And for the numerator, we don't have a shortcut to do this. For the numerator, we have to use a FOIL. So let me do it here. Okay, so we get 23 times 3 and plus 23 times I and plus negative I times 3 and plus negative I times positive I. So I have 23 times 3, this is 69, and this is 23I, this is minus 3I, and this is minus I squared. So I have 69 plus 20I, and since I squared is negative 1, so minus I squared, it's like minus a negative 1, so this is plus 1. So the numerator is 70 plus 20I. Okay, then to rewrite this answer into the form a plus bi, we just split this into 70 over 10 plus 20I over 10. Now let me erase this. So the answer is 7 plus 2I.